Hi, I'm Scott Ford, the co-founder and CEO of Corgibytes, a company that focuses exclusively on helping teams make their systems more stable, scalable, and secure. We work with existing systems. We don't build new systems from scratch. And that's our passion. We really, really like doing it. And today I'm going to talk to you about something that's really become important to me over the last few years. And that's the idea of measuring dependency freshness, measuring how out of date your dependencies are in your system, and looking at a metric that I stumbled across for how to do so. So like I said, I'm Scott, and something else that is important to know about me is that I absolutely love to fix bugs. It's one of my favorite things to do. When I'm given a brand new code base to explore, and I see that there's a really long bug list, I get really excited. Diving in and fixing those is something that just makes me giddy. And there are other people on my team who get equally excited about it. And another thing that I also get excited about is upgrading dependencies. And, you know, again, like I mentioned earlier, like I like this so much that, you know, the company that I co-founded focuses on just helping teams make improvements to the applications that they have. And for years, while we've had this focus, it's only been recently that we've really started to pay a large amount of attention to the dependencies that the systems we're maintaining and the systems that we're improving or taking advantage of. We would often come across clients that had dependencies that were maybe a couple of years out of date, but we didn't really stress out about it too much. We figured that as long as there wasn't anything the customer was wanting out of a newer version, that there wasn't necessarily all that much of a push to really upgrade. We would push when we discovered that there were known vulnerabilities. And so, we would occasionally look for those and keep an eye out for them. But out-of-date packages were something that we just, wasn't all that important. We figured that people would upgrade when they were ready and it would be no big deal. But then this happened. So back in 2017, Equifax was hacked. There was a big, massive data breach. And looking into the details of why this breach happened, we learned that it wasn't because there was some custom code that was developed and an attacker found a vulnerability for how to exploit that custom code within the system. No, in this case, the problem was that the team didn't keep their libraries up to date. And I'd like to pause here and say, I look at code bases with the assumption and the understanding that everyone is doing their absolute best. And I suspect that Equifax doesn't hire, incompetent people. The team they have was top notch. They were doing the best they could with the circumstances and constraints and things that they were being asked to do. Taking all that into consideration, they were doing their absolute best. And still, this happened. So I think it's still worthwhile to look at this and learn from it and say, okay, there was a critical bug in Apache Struts that had been fixed in March of 2017. And then in May, it was exploited. So there was a 2-month window when the fix was out there in the open and the team could have upgraded. There was an opportunity for the team to upgrade and avoid the bug, and they didn't. So why does this happen? And because this isn't the only code base that I've ever looked at that had out-of-date dependencies. And again, 2 months isn't that big of a deal. I've seen systems that have dependencies that are several years out of date. Relying on critical components that I'm pretty confident have very known security vulnerabilities. So why don't these things get updated more aggressively? Why do systems get left to accumulate this very specific kind of technical debt? So when I really kind of step back and look at it, I think one reason is fear. And I think it's fear that the new version of the dependency is going to cause a bug in and of itself. So just deploying a newer version might cause a failure. And it might cause a failure in an unknown way because the way that the system that we have control over interacts with this dependency that we don't have a control over, that interaction isn't always super well understood. And sometimes we don't have a lot of trust in the team that's putting out the new version. So we feel like we have to like really exhaustively test the libraries that we're upgrading, or really exhaustively test our entire system anytime a library gets upgraded. And that fear kind of leads to that behavior of like, we really, really have to be sure. And that's kind of where the second problem for this comes into. It was just time. The time that it takes to be sure, the time that it takes to be safe about it, the time that it takes to research whether or not there's any other known issues that you might be adopting by upgrading, the time that it takes to fix any incompatibilities or breaking changes that the new library might have introduced. It's often the case that in order to upgrade to avoid a security vulnerability, you sometimes have to jump to a newer major version, and those almost always have breaking changes, especially if the version of the library you are using just isn't supported anymore. It's not going to get a security fix. The security fix was applied in a newer major version of the code base. So if you want to avoid being vulnerable of that flaw, you have to upgrade to a newer version and then figure out how to contend with those breaking changes. And all this is to say that dealing with these things doesn't necessarily add a lot of obvious visible value to the people who are using the system and to the people who are relying on it to do its job. So this is an activity that tends to get pushed down on the priority list. It's something that can be wait till later. It's seen as really risky. It's seen that it will take a lot of time, and the benefit isn't something that's easily observed. So it gets pushed on the priority stack. And then there's also this perceived difficulty that comes into play. So kind of like the fear, the time, the priorities, those are all kind of influenced by this idea that it's going to be incredibly difficult. It's going to be very labor intensive, and that there's no way to avoid that. And I think, that's true for a lot of systems, but it doesn't have to be. And we'll get into that in a little bit. And I think another aspect of this is kind of like, this kind of goes a little bit hand in hand with the priorities issue, but it really is an invisible problem. I mean, the system will largely continue working, if a dependency gets out of date. It's not all that, it's not easy to see. It's not visible. So that's kind of gotten me thinking, like, well, if it was more visible, would we pay more attention to it? And so that's kind of where I've started exploring ways we could measure how out of date the dependencies are. And that's when I stumbled across this idea of dependency freshness. It's a term that was it's a term that was coined by Joel Cox to describe the quantification for how out of date an application's set of dependencies are. The idea being that the more fresh your dependencies are, the closer to the recent versions you're using. And I really like this idea of kind of freshness as a metaphor, because I think it really has a lot of appeal when you're talking to people who aren't used to working with software all the time. We think of like fresh fruit and fresh salad, and if you leave those things to sit without having much attention, they start to rot. And then also, I think keeping up to date with your dependencies, really reminds me a lot of like brushing your teeth. And the goal is to, have a clean mouth. And, there are like, the guideline for my dentist anyway is to brush my teeth twice a day, once in the morning and once at night. And, I've had other dentists who have recommended that I should be brushing after every meal, or, I had, when I had braces, I even had guidance to like brush more often than that. So it is a little situation dependent, which I think makes sense here because a lot of software systems, vary from situation to situation. And it's not like the expectation isn't to be brushing your teeth all the time. That would actually be damaging your teeth. Like if you brushed your teeth all the time, then you would wear your teeth down and they wouldn't, do their job anymore. So, but the idea is to like, keep them fresh and keep them clean. So it's like, like kind of thinking of it this way, it's like minty fresh software. And the longer it's been since you last, cleaned things up, the less fresh your breath is. And, in this way also, it's, if you are keeping your dependencies up to date, on a regular schedule, or at a, in a regular cadence, then your software system is more fresh as well. So I think it's also important to think about the brushing your teeth metaphor and kind of flip it around and think and examine the consequences of not brushing your teeth. Because there are consequences of having dependencies that are really out of date also. But the consequences vary depending on whether or not you're a developer who's actively working on the system, or whether or not you're somebody else that's with a different role on the team of software. For the developers, it's often that you end up with a system that's difficult to work with. So you have a library that could be difficult to install. It's becoming more and more challenging. There's more information about how to work with newer versions. Documentation for the existing version becomes harder and harder the documentation for the existing version, the latest version, is the documentation that's easiest to get your hands on. The documentation for the version of the dependency that your system's using, especially if it's several years out of date, that might actually be hard to get your hands on. You may also have problems with other libraries that are interacting with this library and kind of have like things that need to upgrade in sets. And so you may have, one dependency in your system that is really kind of holding a lot of others back. Even though you want to upgrade, you're finding yourself in a situation where it's very difficult to. And that's often because, these third-party libraries support can often be lacking. Like, you're, even if it's another company that you're actually buying this from, support for an older version isn't going to be around forever. And, at some point, pretty much, every software team that I've been on anyway really wants to find a way to stop supporting really old versions of the software systems that they're working on. So that's, something that becomes more and more painful over time as well. So let's flip this around and look at the kind of what's painful for the organization. So ways this shows up for the organization as a whole is that developer productivity is significantly impacted for a lot of the reasons that we mentioned. And it's not impacted all at once. It's kind of slow over time, slow build up. It's not the kind of thing that you can really kind of, point at and say like, oh, it got worse on this day. This is when it really started to get bad. It's something that happens really gradually and it's really hard to notice. Another thing that happens for organizations is that the amount of risk that the organization is taking on in terms of security vulnerabilities goes up over time. The longer that a dependency has been out there, the longer it has been a target for being attacked. And if there is a vulnerability, then people have had more time to build sophisticated ways to exploit it, and automated ways to exploit it, or automated ways to detect systems that might be vulnerable to that exploit. And so, the risk that you're kind of going to get caught, that you've got a system with a vulnerability, goes up and up as time goes on. And so, I think it's important to acknowledge that. And, if the worst happens and you do get hacked, then you have, fallout from that. There's, public relations challenges. Customers start to lose trust. You could be facing lawsuits. It could get bad. I imagine it was a very expensive situation for Equifax, and it was probably a big shock to them, and not the kind of thing that they're really planning on spending money on that year. And if you kind of think of your team's budget, and if it was impacted, it was suddenly hit by a huge legal bill because of a exploit, that'd be pretty rough. So again, I think these are challenges that we would work harder to avoid if the problem were more visible, if it wasn't something that just kind of gradually showed up over time. And that visibility, I think, can be aided by some kind of diagnostic tool and maybe even a metric. And so that's why I'm going to be talking about LibYear. So LibYear is a metric that's designed for measuring dependency freshness. And something that I really like about it is just how simple and concisely it can be explained. And this picture is taken from the website libyear.com. And the idea is it's a way to kind of quantify how far behind a project is, so that you can compare two projects against each other to get some kind of evaluation for prioritizing which one you should upgrade. Because in the before situation, talking about it is kind of hand wavy. It's like, oh, they're out of date, it's really bad. And whereas if you have a number and you can say, it's in this example, it's 120 years behind, and then you're comparing that to another project, and you're like, oh, that other project is only 42 years behind. And so you could maybe say like, oh, that other project was hacked last year, right? And they did work to update the dependencies since then, and that's why it's at 42. Maybe we should do some investigation into the one that's at 120. So you're able to then have kind of conversations because you have this comparison point between different systems. So that's kind of where we get into kind of the benefits of LibYear and like why it becomes a good metric for looking at dependency freshness. And one is, I think it's very easy to compute. It has the advantage of distilling dependency risk of the entire system down to a single number, which makes it very easy to communicate. And I've noticed that it can provide even more insight when you graph that single value over time and observe trends in the kind of the behavior of the development team and their maintenance practices over how much effort they're putting into keeping the dependencies up to date. So let's dive in a little bit deeper and let's look at how to measure LibYear manually. So before we look at any tools that might do it, let's really look at how do you compute this? And it's pretty simple. So you first have to compute the LibYear metric for a single package in your system. So you look at any one package that your system is depending on and go out and grab the release date of the latest version that's publicly available. And here I usually use stable versions unless you happen to be using an unstable version, in which case I think an unstable version makes sense. But in general, latest stable version is kind of what's meant by latest version. And then you get the release date of the current version, which should be in the past. And when you subtract them from each other, you get time measured in days, weeks, months, years, and if you report that in terms of years, it might be 0.1 year, for a particular package. And so now you have that one package's LibYear value. So next is to do that across your entire project. So every package that your application is depending on, you iterate over all of them, compute the LibYear for each one, and then add those all together. And then you've got the LibYear for your entire project. So like I said, it was pretty simple to compute, and like there we go. Like it's really easy. So, but nobody wants to do anything like that by hand, and I've done a couple of them by hand, and it's not fun to test tools. But so that's why we have software. We write software to do these things for us. So there are a lot of packages that are out there that will measure LibYear for different language ecosystems. You can find a list of some of those at the libyear.com website. Up here on the screen, I have a screenshot of one of them. This is a I'm blanking on what language this one supports, but this is a system that computes LibYear, I think for Python code bases. Yeah. So let's look at an example of what it looks like when it's running. So here we're going to show it running against the PySpider open source application. And so what you get in the console is pretty simple. You get the per package LibYear values, the current version that's being referenced by the requirements.txt file, and then the absolute latest version, and then for that particular package, how many LibYears out of date is that package. And so we kind of skim down this list, and then when this command was run, PySpider was at 69.8 LibYears, behind the latest. So while I think like having a really good spot measure is useful, I think there's even more power in seeing changes in some of these metrics over time. And so I sat down and I started trying to write a blog article to explore, what graphs like that might look like for different systems. And then I, ended up writing some scripts to do that, and those scripts became more and more sophisticated. And then eventually I had a small little tool that I was building on my hands, and then started calling it Freshly. So Freshly is a tool that we were working on at CorkyBytes to help with measuring the LibYear dependency freshness metric, with plans to add ways to measure other dependency freshness measures in the future. So Freshly, you can find at github.com/CorkyBytes/Freshly, and you can run it on PySpider, and you can use it to generate a graph like this. So, this is a little bit more useful. It's showing the shape of the dependencies and how out of date they've been over time. And as I've dug in and looked at LibYear and kind of graphing it over time and looking at kind of different ways to interpret that information, I've discovered that the shape of the graph of the max LibYear is the exact same shape as the total LibYear. And I imagine if I had a better understanding of statistics, I would probably know exactly why that is. But you end up with a graph that's the exact same shape. But the numbers are a little bit easier to reason about and to understand. So when we're looking at the max LibYear, it's the package that has the highest LibYear value at that point in time. So what Freshly does is it computes the LibYear across the code base. So it looks at so like requirements.txt file in this example, and it gets every version of the requirements.txt file, and it computes the LibYear going back in time using those files as a reference to say, okay, what was the LibYear a month ago? What was it a month before that? What was it a month before that? What was it a month before that? And it keeps going until it gets to the age of the dependency manifest file. So in this example, we've got dependency history going back all the way to before 2015. And we can see that when the project started, everything was up to date. And there's like a little blip between 2015 and 2016 where things got a little bit out of date, but it came right back down to zero. So where the team was using the absolute latest. So we can kind of imagine that this might have been a time period when the application was maybe really popular or really well supported. We can guess at those things. We can't really know why. But then we look and we see that it started to creep up and then kind of plateau in 2017. Why it plateaued, not really sure. It creeps up again and plateaus, creeps up again and plateaus, creeps up again and plateaus. And then there's a huge spike near the end of 2019, right before 2020. And if we look at what was going on in the Python ecosystem at that time, that's about the time when Python 2.7 support was getting phased out of a lot of packages because Python 2.7 was no longer supported by the Python community in general. So there were a lot of packages that got updated kind of all at once. So then you had newer versions of packages coming out that might not have been updated for a while. And so this has kind of caused a little bit of a spike in the graph. But, kind of looking at this and saying okay, so there's one package out there now that has a LibYear of 7, but which one is it? So you can kind of take a look at that too. And you can graph each individual package and how out of date it's been over time. And so here we can see the same shape as the graph before, but it's a little bit noisier because there's a lot more dependencies going on. And we can start to use this to zoom in and look at individual dependencies and see which ones are kind of contributing to the score. So let's do another example, looking at another code base, this time a Ruby on Rails application, feedben, which is a RSS reader. And so here we see that the team kind of started out with the project max being 2 years behind. So they had one dependency that was 2 years behind when they got started. They paid that down to about a year and a half out of date was the kind of the max. And then things went up, brought back down, went up, brought back down, went up, brought back down. And then you can see a lot of effort was put in early in 2020 to bring things down, but then you start seeing them tick up again. And again, we can look at the per package values here, but again, this is a graph that gets really noisy and really busy and really hard to read really quickly. So if you zoom in and kind of look at what's going on, what's the latest, you can kind of see that it's Elasticsearch, the Elasticsearch Ruby gem that was contributing to the max Libir being at 3. And if that package were updated, it looks like the Libir max would fall to 2.5 or something like that. And it does look like there's a fair number of packages that are kind of clustered around in there. So it looks like a fair bit of work would be needed to get this project probably down to 0. 1 is probably achievable without a whole lot of effort. It looks like it's maybe only 6 or 7 packages that need to be updated to get it down to 1. But that's kind of something that can help. And I think these graphs can be really useful at helping communicate the current state of how out of date the dependencies are, the way they've been changing over time, and can help teams make informed decisions about where does it make sense to apply energy to actually do these upgrades. So I'd like to talk a little bit about kind of the future of the Freshly project and kind of where we see it going. And really kind of state that one of the first things we did when we started working on it was really kind of define its mission. And its mission is to create tools that clearly illustrate the financial risk of deferred software maintenance. So finding a way to communicate to people who are paying for software what the impact is and what kind of risk they're carrying by keeping dependencies that are out of date. And kind of with the vision being that software systems will eventually be self-healing and out-of-date dependencies will kind of become a thing of the past. I really do envision a future where keeping dependencies up to date is a problem that's been completely automated away. And I think we're already seeing glimmers of that with the tools like Dependabot, partnered with continuous integration systems, where and then also teams that have auto merge and auto deploy set up. So you can have a continuous deployment and a continuous integration pipeline set up so that Dependabot notices that there's a new version of a package. It opens a pull request for that new version. The test suite kicks off on that pull request. The test suite passes on that pull request. So the pull request is automatically merged. The merge to main kicks off a deployment to production. And then the new version of that package that, is out in production for your application within, however long it took to run your test suite and do your deploy, which for a lot of projects is, under an hour. So within an hour of having a new version of a package come out, you're updated. And, if you have enough confidence in your test suite, then, you know that it's relatively safe as well. So I think, that's the future that I, really like to see people get to. And when you look at projects that are using Dependabot, and you look at the dependency graph, it just falls to, like, you look at the dependency freshness graph using LibYear, it just falls to zero. It becomes a meaningless graph. And so I think, really kind of showing that story and showing how, like, the engineering discipline that it takes to stand up a pipeline like that really could have benefits, because then we can kind of look back to the business problem of what if Equifax had that, right? And if Equifax had that back in 2017, when the newer version of Apache Struts came out, then they would have been vulnerable to that security vulnerability for as long as it took to run their test suite and do an automated deployment. Now, the engineering effort required to get there is quite a bit. So, I'm not trying to diminish that, but I think that's definitely within reach. So, and I think it's something that, like, we should really be striving to push our systems towards. So, I'd like to also think about, like, kind of the best next steps to take with Freshly, and kind of exploring this area of dependency freshness and kind of, how to really make good use of it. And I think, one of the things we've identified is that LibYear is a really good metric for showing just how out of date something is, but it doesn't really tell you, like, how much risk you're taking on in terms of security vulnerabilities. So I think it would also be interesting to be a computer metric to say, like, on this date, how vulnerable was my package, were my packages, and developing some kind of metric, I think similar to LibYear in terms of its qualities, in that it's easy to communicate and easy to reason about and easy to compute, but would also kind of communicate the amount of risk that is present in a package in terms of, the number and the kinds of security vulnerabilities that are published at that time for it. Another challenge that we've noticed with LibYear is kind of the way it gets added together. It can become difficult to kind of compare it across projects, especially when you're looking at the total LibYear across an entire project. So we can think of a LibYear of 100, and we can have two applications that have a LibYear of 100. And kind of in one extreme, we could have one project that has 100 dependencies, and each one has a LibYear of 1. So then the total LibYear for that project will be 100. We could have another project that has 2 dependencies, each one with a LibYear of 50, and its total LibYear would still be 100. But if we were comparing these two projects, we might get the sense that they're equally up to date. And they're kind of not. The one that has the one with the 2 dependencies that are 50 years, I would think is in worse shape than the one that has 100 that are all at 1. So that's why we started kind of looking at the max as being something to look at over time. And I think maybe starting to use that for comparing projects to determine, how much effort is needed to put into it, or maybe a measure of risk, if not effort. But I think that's a value that is kind of plays an important part of the story. And I think just doing the max is something to consider as well. And then I think also providing some more guidance about what is a good value, like what makes sense to be an acceptable, value for something beyond out of date. On the graphs that I showed earlier, we drew like a threshold line at 1, for 1 year for the max for any one package. At LibYear.com, the recommendation is that a good application, has a total value that's less than 10, for applications. And then the team that helped create LibYear, they regularly start working with systems that have LibYears of greater than 100, and so they work to get them down to less than 10. And so I think if we think of a code base with a lot of packages, that could be a lot of packages that are maybe just a month out of date. If you have enough of them, it would add up to a total LibYear of 10. So I think it's a measure that's going to scale probably more quickly based on the size of the application and the number of dependencies it has. So I think getting some rubrics for, like, if you have this many dependencies, this is a good value, and if you have this many dependencies, this is a good value. And I think kind of exploring that and kind of coming up with some opinions around that would be good to explore. If you're interested in getting involved in Freshly and kind of helping out, we're building a fair bit of it as an open source project. You can go to github.com/querybytes/freshly. And then we also have a CLI project, which is freshly-CLI. And some things that, would be awesome would be to, like, explore adding other metrics. So the paper that Joel Cox wrote that introduced the kind of the concept of dependency freshness has a few other dependency freshness measures that we could add support for. And I think it would be pretty neat to see how those might compare over time when, kind of graphed against LibYear. And, so you can look up his paper and kind of, see the details of that. And then, look at those metrics, or, maybe invent your own metric. Like, is there, maybe there's like a Semver based way to kind of compute a metric for how out of date something is, in terms of how many major versions behind it is and how many minor versions behind and how many, build or patch releases it is behind. We're also looking to add support for more ecosystems and more dependency formats. So we're building Freshly with the assumption that it will be able to pretty much analyze any repository and find all the dependency manifest files that are in it and analyze those. And so that means kind of adding support for a lot of different language ecosystems and all the different ways that many different language ecosystems measure dependencies. There are some language ecosystems that have 6+ different competing ways for keeping track of dependencies. And so, having really rich support for those language communities would be nice, and I think is might be challenging. So, but if something you're passionate about, it's definitely an area where you could help out. And then I think really kind of improving the graphs. So the graphs that I showed today were created using a Jupyter Notebook. So we've got instructions for how to use Freshly inside of a Jupyter Notebook to generate these graphs. But I think we could look at other ways to analyze the data and produce really visible ways to see how this data is changing over time and kind of what conclusions might be able to be drawn from that. So that's definitely an opportunity as well. So, like I said before, kind of like if you only take one thing away from this talk, I want you to walk away with the idea that auto upgrading all of your dependencies within minutes or hours of when a new version is released is achievable. And furthermore, I think it's possible to even be tracking ahead, so that you could, if you've got your system, the absolute latest version of a dependency, you can be making sure you're testing against release candidates, and you can be making sure you're testing against, beta builds of those libraries. And then you've got an avenue to give feedback to those teams. So, maybe they weren't aware that they've introduced a breaking change. Or you can, let them know that it's going to be a very painful breaking change for you. And maybe they'll, help you add support for making that upgrade easier. But then it creates a better path for kind of communicating with these teams and letting them know kind of the impact of those decisions. And we'll kind of let you be aware of, hey, this next release is going to be hard. Maybe we should start planning for it. And that's something you can you can start planning for in a proactive manner instead of having to feel like you're chasing it in a very reactive way. So lastly, I'd like to say thanks for having me. I really appreciate being able to speak at the Scottish Summit this year. And thanks a bunch. And if you'd like to get in touch with me and kind of ask any questions or kind of keep the conversation going, here's my contact information. And yeah, thanks a bunch. Chat with you later.